Software engineering historically relies on deterministic execution. Systems follow rigid paths, ensuring specific inputs flow through the logic to identical, predictable outcomes every time. The traditional software development lifecycle, or SDLC, is engineered to answer a single question: did we build the software correctly? This process assumes that if the application logic is sound and the features are bug-free, the system's behavior remains entirely contained and explicitly defined by the written code. AI agents operate under a different set of constraints. An agent interprets fluid context and makes bounded decisions under conditions of uncertainty. The agent coordinates external actions and produces real-world effects across highly unpredictable environments. When you place a non-deterministic agent into a traditional deterministic pipeline, the core assumption of predictability shatters. Outputs are no longer mathematically guaranteed. A single model evaluation can dynamically trigger downstream integrations that the original developers never explicitly hard-coded. Correct code does not equate to a controlled system when the software itself participates in the decision-making process. A common operational mistake is treating machine intelligence as a standard application feature, a module to be dropped into an existing architecture. In the Agentic SDLC, intelligence serves as one component within a much larger, highly regulated infrastructure. The foundational question expands. Architects must now ask, did we design, constrain, verify, and operate agencies safely and effectively? This forces a reevaluation of requirements. Architects must define the specific parameters of what the system may decide. You have to define what evidence the system must prove before taking an action, and the specific thresholds where it is required to halt and escalate to a human. Traditional architecture relies on design time structure. Agentic architecture requires strict, active, runtime control discipline to maintain boundaries. The Agentic SDLC focuses on constructing a governable system of action. Traditional system behavior originates exclusively from code and static configuration files. Agentic behavior emerges dynamically at runtime from model outputs, policy as data, and live, fluctuating signals. Engineers are historically trained to hunt for specific failures, like basic syntax bugs, complete server outages, and broken API integrations. Look at the right side of this failure matrix. These are new failure modes specific to autonomous systems, invisible to standard unit testing. Consider unsafe autonomy. An agent triggers an unapproved external effect despite flawless code. Semantic drift occurs when the agent misinterprets dynamic context. Finally, unprovable decisions happen when an agent acts without telemetry, leaving operators unable to audit the choice. Standard CI/CD pipelines optimize for functional correctness and application security. They allow these runtime behavioral failures to slip directly into production environments. Because behavior is shaped at runtime, testing and operations must expand to monitor the context and intent of the actions, ensuring the system remains governable. Mitigating runtime failures requires an expanded design phase. Governance infrastructure must be treated as a first-class engineering priority. Before writing logic, architects must construct 6 foundational pillars to constrain behavior. 1. Intent design defines the core goal and negative space. 2. Boundary design establishes operational authority. 3. Semantic design engineers shared meaning. 4. Policy design creates machine-readable runtime constraints. 5. Protocol design builds explicit coordination logic. 6. Assurance design integrates evidence and provenance tracking natively. Without these interlocking constraints, developers are merely unleashing an unpredictable black box. When you integrate those pillars into production, the traditional 6-step CI/CD pipeline morphs into a more comprehensive 12-step sequence. This is the Agentic SDLC timeline. Design flows into rigorous simulation and verification, proving containment across contexts. Deployment activates a governed system, requiring perpetual supervision. Operations handle exception routing, ensuring every agentic decision maintains traceability to human escalation paths. Finally, runtime data loops back to refine boundaries, creating a continuous, closed-loop system. Maintaining runtime control over a probabilistic entity requires constant adjustment. The outer structures must shift continuously to contain the volatility of the center. Having perfectly correct code does not ensure the system is under control when it is capable of participating in decisions. This schematic represents a properly governed agentic system in production. The AI model is only a fraction of the architecture. It serves as the engine. The surrounding layers, policies as data, boundary APIs, and escalation paths, are the guardrails. They dictate what the model triggers. In this era, change management requires versioning policies, semantics, and operational boundaries with the same rigor applied to the code itself. To safely deploy autonomous technology, modern architects must commit to engineering governable systems of action.